इस पे आ रहा है कि नहीं? मुझे
क्या अभी तो इसमें
Yes, yes, you're audible. Yes, yes, I am able to hear you guys. Yes, I am able to hear you guys.
यहाँ पे कुछ नहीं आ रही ना, दिखा नहीं Understand. Accept that. Understand.
नहीं माइक ऑन and you have to open terminal over there. Once the terminal is open, here are some of the commands that you need to run. The first one is of to generate the cluster UUID, which is given over here. I'll not hit this one because I have already set up the cluster UUID. The second command is of the format log directories that is required to initiate the server, and final command is to start the Kafka server. So as I have already set up it, we'll just need to uh, hit the this command to start the server. So the server is being started now. Yeah, it is still processing. Okay, now the server has been successfully started. So now we'll see how we can actually integrate this to Spring Boot. Let's move on to the Spring Initializer, where you have to set up two projects or other application. The first one is to create a producer app or project where the important dependency is of the Spring for Apache Kafka. Actually, there are two dependencies. Intentionally, we are using messaging one because we are using pub sub model. The second one is of the streaming, which is also which can also be used. In the similar way, you have to create another project related to consumer in the same way, the same fashion, and the dependencies are also same. So once that is being done, you just have to unzip the file and open your Spring Boot app. So let me quickly show you the pom.xml file, that is where the all dependencies are being there. The Apache Kafka, like Spring for Kafka, is there. After that, the here comes the application.properties file, wherein we have configured some of the things that are related for the producer and consumer as well. So there is server port on which this application will be running, and there is another server for the producer, that is localhost 9092, as we are running it on localhost. And we have configuration for string serializers because the keys of the message is considered as string, and then the value or the key is converted to byte array. So this is how the configuration looks like. Uh, Apart from this, we do have to mention, or rather keep a Kafka config file, which is a bin type of new topic, uh, which is uh, which is producing a topic with the name that I have provided in the constant, that is patient details, and it is using builder design pattern. So this is the important one. Then we have a controller. Basically, in order to test the API, we'll be needing a controller, and here a request is there of the post mapping, where in the request body we are using some patient details to produce for the topic, and the send patient details is the method from where actually the details are being sent to the brokers, rather the message, where I have intentionally kept a for loop over here so that you can able to differentiate how fast it is in terms of handling. So for that, I have also intentionally introduced a slip of 6 seconds to see the actual difference. So this was the producer app, and in the similar way we'll also look for the consumer project as well. The configurations are quite similar. uh, we have same, like the port is changed over here, and the remaining configurations are same. So we have service over here where a Kafka listener annotation is used that requires a topic name. It should be same where, which the producer is being produced. The same topic name should be there, and we have group ID over here because there may not be the case where only one producer and one consumer will be there. In real world, it's not at all the same. Of course, multiple consumer may subscribe to the same topic at the same time. So for that purpose, group IDs are there. In our case, there is only one consumer and producer. Of course, you may explore it more, and you can leverage the data that is being present in the documentation, and the things that needs to be done to that. So let's start both the servers. I'll start this application of the consumer, and a similar way I'll also start uh, the producer application as well. So this way we have started both the application. So we'll check via Postman, like how it actually functions and how the message are being consumed in a rapid manner. Like within seconds, the data is will be processing. So we'll go to the Postman, and here is the API that is request that is which is accepting the patient details, like that these details might be anything, just for the purpose of showing. I have used over three. The first one is of the temperature, heart rate, and blood group. This might be anything, like don't go in the unit, because this is just for showcasing purpose. So we'll hit the API, and we'll see how fast this works. Like this will continue for 5 loops, because I have intentionally kept the iterations of 5 over here. And for the delay of over 6 seconds, it is being producing, and at the same time, with the just the difference of minimal fractions, it is being consumed. So if you actually check the time here, and like the time when the message was produced and the time when it is consumed, there is only difference of almost say 2 milliseconds. So this is the magic of Kafka that lets you the real-time data processing and real-time event management. So of course, this is the case where only one producer and one consumer was there, but there might be a case where multiple consumers are also present. So for that, you can always have a play around with it. So this was the part of demo that is practical that we have seen. We'll again jump onto the uh, PPT, because we have to see the advantages of Kafka. Like as I told, there are many advantages, but what is the USP, like unique selling point of Kafka, that makes it uh, more useful in today's world? So it has high throughput and low latency. High throughput means in minimal amount of time we can have read and write operations. Like it is designed to handle massive data volumes with extremely low latency. So it achieves this by using distributed architecture. Like data is being distributed over the brokers, and if any of the failure occurs, so that there is a always backup of data, it ensures that. So Kafka processes messages in batches, which reduce disk IO operations and increasing efficiency. Even in high load environments, Kafka maintains the consistent performance due to its efficient use of memory and disk. The second point is of scalability. Yeah, this is important, and as I already told, like this is important in healthcare too. So Kafka is built to scale horizontally, meaning that you can add as many brokers as you want. It supports automatic partitioning and rebalancing, which ensures a balance, application. And Kafka also allow you parallel processing, ensures that multiple consumers can read data concurrently. So this is what really a Kafka makes a highly scalable platform, which also allows companies to handle increasing data traffic without major architectural changes. The fourth point the third point is of durability and fault tolerance. Durability is being ensured by Kafka through replication, where a message is published, it is copied into multiple brokers, and there we have a backup of data. So this makes Kafka reliable and fault tolerant, and it is also automatically recover from failures without any of the data loss, because patient data is like highly important when it comes to healthcare. Then decoupling of microservices. Let's understand this by where Kafka act as an event-driven middleware that allows microservices to communicate asynchronously. So right now only we have seen, like we were having two services, that is the producer and the consumer, where the communication were taking place seamlessly. So instead of direct API calls, services produce and consumes messages through Kafka topics, and which reduce tight coupling between systems. So this enables better scalability, easier maintenance, and more flexibility in deploying and updating microservices. Then replaying events, which we usually call as log retention. So what does mean by log retention? So Kafka generally store messages from for a configurable period. Let's say when the message is produced from that uh, from that days or weeks, uh, it has to be produced in the list. So till the time it is being consumed by the consumer. So this allows consumer to reprocess message if needed, like making it useful for debugging and also there are some use cases like event sourcing, where past event needs to be known, like it needs to be replayed. So this is important, and it is widely used where used in financial transaction, right, where each and every transaction record must be checked, and also auditing, and the time where you are ready to apply for the insurance policy, right, there are some mandates that needs to be completed by the insurance side, insurance provider organization side. So at that time this is very important. Then it has a multi-consumer support, meaning Kafka allows multiple consumer or consumer groups to read messages from a single topic independently. So this means that different services can consume the same data stream for various purposes, such as analytics, monitoring, and storage, without interfering with each other. It also support load balancing across consumers, ensuring parallel and efficient data processing. So yeah, then the last point is of the big data, which like where LLMs models are being used inside healthcare to efficiently do the uh, process. And this is the case where there are some points where you need to keep in mind while considering Kafka. There, that is the high throughput and scalability. I've also discussed this earlier, where there is always a chance of high throughput and scalability if you are using Kafka. Microservices communication, that is for if you have more than two microservices, then the communication goes very seamlessly with Kafka. And real-time analytics and data pipelines, because real-time data is highly needed if you are considering Kafka, especially in healthcare. I mean, there are other cases as well, but in healthcare, it is very important. And reliable and durable message processing is important because this is what Kafka is providing us. So let's conclude this session where we have discussed the importance and introduction of Kafka, where we have also seen the architectural overview, where we have seen the components of Kafka like producers, consumers, brokers, which manages the Kafka server. Then we have seen topics and partitions where each and every message is being produced through a topic, and inside that topic we may have multiple partitions as well. Then we have seen the Kraft and Zookeeper difference, where Kraft is being introduced recently in the 4.0 version of Kafka. And also we have seen some of the features that Kafka provides us, right, from fault tolerance, scalability, real-time data processing, and high throughput things that are very much important in healthcare. Along with that, we have also seen the live demo where we have showcased how the communication is being processed via two services, especially from producer and the consumer. So these were the today's session. Please let us know if you have any of the questions, or do you find the things that are not clear. Or feel free to ask the questions. You can ask the question in the chat. Yes, please. Any questions?
So I think everybody has understood everything. So let's move forward. So next we have a quiz that is for you. And before the quiz, please enter your valid email address. Winners will be finalized based on the score and the fastest to solve the quiz. Top three winners will get the certification, and all the other winners will also get a participation certificate. So I'll just post the link on the chart. So you can start with it.
Q&A session.
So just 1 more minute left. So thank you all who have participated in the question answer session.
So if you do still have any of the questions, you can feel free to reach out to us. These are below the emails that we have provided over here. In case if you have any questions, you are feel free. You can feel free to ask. Yeah. Thank you.
The recording has been stopped. Thank you for joining.